Let E be the solid below z equals 8 minus x squared minus y squared, and above the square region over this interval here in the xy plane, where this first closed interval is a closed interval for x, and the second closed interval is a closed interval for y. Given the solid has a constant density of 7, we're asked to find the moment of inertia of E about the z-axis. The moment of inertia about the z-axis is given by I sub z, this triple integral here, where we have the triple integral over the region E of the quantity x squared plus y squared times rho of x comma y comma z, where rho is a density function, which in our case is just the constant 7. Let's begin by looking at the solid region E in space. So the solid region E is this bounded region here, bounded by x equals 2, x equals negative 2, y equals 2, and y equals negative 2. Above the xy plane, also graphed here in yellow, the bottom, and below the surface, graphed here in blue, of z equals 8 minus x squared minus y squared. Before we find the moment of inertia about the z-axis though, let's review what the moment of inertia means. The moment of inertia, otherwise known as the angular mass or rotational inertia, of a rigid body determines the torque needed for a desired angular acceleration about a rotational axis. It depends on the body's shape, mass distribution, and chosen axis, with larger moments requiring more torque to change the body's rotation. So again, here we're asked to find the moment of inertia about the z-axis. So we have I sub z is equal to the triple integral, where the integrand function is going to be the quantity x squared plus y squared times 7, because the solid has a constant density of 7. So the integrand function is going to be 7x squared plus 7y squared. And for differential v, we'll use the order of integration given by dz dy dx. And now we need to find the limits of integration for z, y, and x. Well, we know z is bounded by the xy plane, and z equals 8 minus x squared minus y squared. The equation of the xy plane is z equals 0. So the limits of integration for z are from z equals 0 to z equals 8 minus x squared minus y squared. And then the limits of integration for y and x are defined by this square region here. So the limits of integration for y are from negative 2 to 2, and the limits of integration for x are the same from negative 2 to 2. And now we first integrate with respect to z, treating x and y as constants. So the antiderivative with respect to z is just going to be 7x squared plus 7y squared times z. And now we need to find big F of b minus big F of a by performing substitution for z. So we'd have the quantity 7x squared plus 7y squared times, well, first z is equal to the quantity 8 minus x squared minus y squared, and then when z equals to 0, we just have 0. So this product here will give us a new integrand function. Let's multiply this out on the next slide. So here we're going to have a total of 6 products. 1, 2, 3, 4, 5, 6. So we'll have 56x squared minus 7x to the fourth minus 7x squared y squared, and then plus 56y squared minus 7x squared y squared minus 7y to the fourth. And now we do have two like terms here. We have two x squared y squared terms here and here. So we'll combine these terms to find the simplified integrand function. So we have 56x squared minus 7x to the fourth minus 14x squared y squared plus 56y squared minus 7y to the fourth. And now we integrate with respect to y, treating x as a constant. So we'll have 56 x squared y minus 7x to the fourth y. Now here we're going to have negative 14x squared times y to the third divided by 3, or minus 14 thirds x squared y to the third. Here we'll have 56 times y to the third divided by 3, or plus 56 thirds y to the third. And then finally here we'll have negative 7 times y to the fifth divided by 5, or negative 7 fifths y to the fifth. Now we need to find big F of b minus big F of a by performing substitution for y. So substituting 2 for y gives us 112x squared minus 14x to the fourth minus 112 thirds x squared plus 448 thirds, and then minus 224 fifths. Minus, now we substitute negative 2 for y, which is going to give us negative 112x squared plus 14x to the fourth plus 112 thirds x squared minus 448 thirds, and then plus 224 fifths. And now we need to combine like terms. We have 1, 2, 3, 4x squared terms, 2x to the fourth terms, and 4 constants. So this simplifies to the integral from negative 2 to 2 of 448 thirds x squared minus 28x to the fourth plus 3,136 fifteenths. And now we integrate with respect to x. So we're going to have 448 thirds times x to the third divided by 3, which is 448 ninths x to the third, and then minus 28 times x to the fifth divided by 5, minus 28 fifths x to the fifth, and then plus 3,136 fifteenths x. And now we need to find big F of b minus big F of a one last time. So when x equals 2, we're going to have 448 ninths times 2 to the third minus 28 fifths times 2 to the fifth plus 3,136 fifteenths times 2 minus, and then we substitute negative 2 for x, 448 ninths times negative 2 to the third minus 28 fifths times negative 2 to the fifth plus 3,136 fifteenths times negative 2. So all of this simplifies to 28,672 45ths. Then we have minus, all of this simplifies to negative 28,672 45ths, which simplifies to 57,344 45ths, which as a decimal would be approximately 1,274.3111. So this is the moment of inertia about the z-axis. And the units are typically kilogram meters squared or pounds feet squared. I hope you found this helpful.